Welcome back to our channel ClassFly Community. So today is the lecture 6 and we will be dealing with waves, and here we will be covering transverse nature of waves, polarization of waves with the explanation and its different types. So without wasting more time, let's begin. So what is transverse nature of waves? So the rectangular parallel pipe does not enclose any charge. So a rectangular parallel pipe doesn't have any charge in the enclosed. Okay. So thus the total electric flux across must be 0. So this law is called Gauss's law, that is E dot ds is equal to 0. So you need to remember that the rectangular parallel pipe does not enclose any charge. So the total flux must be 0. So have you ever anchored one end of the rope and held the other end in your hand, and you did a transverse wave by moving it in different direction? So the electric field here remains the same at each of the points on the x-axis. This proves that the electric field is static in nature. It is known that static fields can propagate as a wave, hence Ex is equal to 0. Okay. Now we will be knowing the polarization of plane waves. So the polarization state is one of the fundamental characteristics that is required to study light. So whenever we study about light, we need to know about this characteristic, that is polarization. There are 3 states of polarization. One is linear, second is circular, third is elliptical. So firstly we will see in detail about the linear polarization. If the polarization of all the electromagnetic waves in a light beam can be made so that each of the electric or magnetic field have the same orientation, then the light beam is said to be polarized. That means if we can make the electromagnetic and the electric and the magnetic field vector is in the same orientation, then we can say that the light beam is what? Polarized. Because of this, there is then a unique plane which contains all the direction of the electric or the magnetic field. So one unique plane will be there which will be containing the directions of the electric and the magnetic field with the light rays. So this type of polarization is referred to as plane polarization, or we can say it as linear polarization. Now we will moving on with the circular polarization. So the second polarization state is referred to as the circular polarization. So the circular polarization can be described as the vectors of the electric field is rotating at a point in the same direction that is perpendicular to the plane of the propagation instead of having any fixed orientation oscillation. So the electric field vector magnitude also remains unchanged. So here there will be a circular polarization, and here the electric field vector will be remain unchanged. The circular polarization can be further classified according to the rotation. Looking at the oncoming light wave, if the electric vector of the light appears to be rotated in a clockwise direction, then we will say a right circulatory polarization have happened. On the other hand, if the light vector appears to rotate in the counterclockwise direction, then the wave is said to be left circularly polarized. So we can also do the further classification on the rotation for circular polarization. So if the electric field of the light appears to be in the clockwise direction, then it is right circularly polarized, and on the other hand, if it is anti-clockwise, then it is left circularly polarized. Then the third thing is the electrical polarization. Then the third is the electrical polarization. So the third stage of polarization is called elliptical polarization. Elliptical polarized light consists of 2 light waves that are linearly polarized and having unequal amplitudes. That means this polarization will having 2 light waves and they have different amplitudes, but their frequency are same. This result in a light wave with electric vectors that both rotates and change its magnitude. So it will rotate as well as change the magnitude. An elliptical shape can be traced out by the tip of the electric field vector, and therefore it is referred to as elliptical polarization. So as there is a traced out by the tip of the electric field, that is why this is known as elliptical polarization. It is also worthy to mention that circular polarization is a special case of this elliptical polarization. The polarization of a uniform plane wave refers to the time varying behavior of the electric field at some point in space. So this line states that the polarization which is having in the uniform plane refers that the time varying behavior of that electric field. So now this is a thing which we can see. So this is states about the linear polarization, where Ey is equal to constant dot Emax. Now Ex. Now in the elliptical polarization we see that the phase difference between X and Y component of electric field will be out of phase, that it will be not equal to 90 degree. And in the circular, the phase difference between the components of electric field will be out of phase by 90 degree. That means the phase difference here will be 90 degree, but it will, phase difference will be out of phase by 90 degree. Here it will be not equal to 90 degree, and here Ey is equal to constant dot Emax. Okay, so I hope all of you understood the lecture of today. Thank you for watching, and if you have any queries you can comment us down below, and you can make your own notes with this video. Thank you very much.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.